my talk will follow on nicely from Chris, so also focusing kind of on that governance aspect of the uncertainty. So I've picked the title, Forging a Path Through Uncertainty. And chosen my words carefully there, that when we're talking about uncertainty, it really is about creating a path forward. It's not about there being some fundamental right way of dealing with it. It's about working out what's going to work in these particular circumstances, given the resources available, time, the skills of the people. And it's really this idea of a path. A lot of the work that we do is precisely iterative. And in fact, one of the most powerful ways of dealing with uncertainty is adaptation over time, to know that I'm going to make a decision now. It's probably going to be wrong, but that's okay because I've planned something afterwards that will be able to catch whatever I've missed. So I also have a title of what is uncertainty, and my angle is slightly different to Chris's. And for me, I'm trying to take it in a rather broad sense, which is why I've added a hyphen here. It's simply anything that isn't certainty. And so here we can see, if we're looking at some change over time, then if we're able to say that there is a single path forward, then we can say we have certainty in the way it's represented there. And then beyond that, there's many ways in which we can approach the topic of uncertainty generally. We might do it in terms of ranges or distributions or confidence intervals, but in some cases, that's not actually possible. All the best we can do is kind of unbounded uncertainty. We have some scenarios, but we don't actually know where the edges are of our distribution or of the 95% confidence interval. In some cases, we also want to combine these. And depending on what we're dealing with, there's a variety of techniques that we want to deal with for that as well. So given I'm saying uncertainty is just lack of certainty, in a modeling context, how is it that we end up with each of these separate uncertain points? And so it's a question of, there's a whole lot of decisions that have gone into our final modeled outcome. Here, a representation of, we had to choose what data we were using, what model structure, what parameters, should have added a representation of the stochastic error as well. And each of these in turn is driven by some higher order decisions we've had to make about what possibilities are we exploring, what views are we actually representing in that model structure, and what methods are we using to try to compare what the model's doing to the data. And so the fundamental problem with uncertainty is, if we do this just once and we get one model outcome, then we end up with just one point. We have this big space of lots of model scenarios, lots of possible outcomes, and we've ended up just picking one point here. And so what we really want to do is explore that space of what are the other ways we could have tackled this problem, what other choices could we have made in data or model structure or parameters, and where would that have landed us? So here we've got the idea of we split up this space of all possible models we could have made. And we're going to divide it up into the ones that result in different options being best. So option A is best up here, option B is best over here, option C here. And the other way we want to divide up all these models is to say, which of these do we actually consider plausible by some criteria? There's obviously a wide range of ways we can negotiate what is considered plausible in a particular case. And so if we're after making a robust prediction, what we end up doing here is to say, are there actually models that exist that are both plausible and give a different option as best? So in this case, we've found one model where option A is best, one model where option C is best, and we couldn't actually find an option where a plausible model where option B is best. And so this is part of the way we can handle uncertainty in this way. But where I want to go through from now is actually following up this idea of there was this process by which we made different decisions along the way. And so it's what I've been working on is the idea of a path perspective on uncertainty. That here we've got a hiker who's looking back on the path they've taken, and they realized there was actually some uncertainty in that last fork. They were standing there at the corner near these trees, and they were trying to work out, should I go left or right? And it turns out in this case, they've gone down the wrong route, they're going to come back and go down the next one, and they're going to have lots of further uncertainty that they have to face. So fundamentally, in the path perspective of uncertainty, we want to ask, what analysis paths are actually possible, and what conclusions do they result in? And what are the possible paths forward for management action, and what outcomes do they result in? So this is a very loose framework that allows us already to start to think very broadly about to what extent should we be investing in reducing or controlling the uncertainty? Should we be investing in better describing the uncertainty in order to make a decision afterwards? Can we actually proceed with what we already know because we know there are stop gaps later, or we can take active management actions? So what I'm trying to do now as part of my project is to try to formalize these ideas a little further. So we can look at it, if we try to describe the actual pathways that were taken in a project. I've even done it for running a workshop. We identify what are the steps that are actually taken along the way. What are the decision forks at which a different outcome would have been possible. And so at that point, the person making the decision had to decide, am I ready to actually choose the next step? Do I need more information before continuing? Do I need to explore further, take a divergent approach and explore alternative paths? And so here, this particular example is showing a case where if we'd gone straight through, we would have actually ended up at a dead end. And it's because the people have stopped and reflected on the result, they've been able to divert to a different path that results in the outcome we want. Another approach I've been looking at is the idea of looking for uncertainty in the arguments that we're actually building. So if we have some conclusion that we're making, it's supported by a series of arguments that build towards it. And where does uncertainty come in? Well, the threat to the conclusion of whether this conclusion should be accepted or not depends on how uncertain the premises are as we go further back. And so there's an issue there of uncertainty framing, of there's ways that we justify why were those original premises actually acceptable for the case that we're after. I'm trying to then scale that up to look at uncertainty in a system-wide perspective. So if we think I'm working in the water domain, we've got a whole lot of uncertainty in the future, in the system, in the values involved, and a whole lot of people involved in monitoring and decision support, water resource governance, the actual water resource users. And all of these people are all facing those decision forks with lots of paths to choose from, with uncertain outcomes. And they have to prioritize which uncertainties are they going to deal with, which ones are they going to reduce the uncertainty at all, do they actually try to explore to quantify what the confidence is or the range of outcomes that are possible. And so they select a range of methods that are hopefully fit for purpose for actually dealing with this. And at the end we have our outcomes both in terms here of water use and its positive and negative impacts, and also in terms of uncertainty management, the direct effects of, it takes time to perform an uncertainty quantification and so on. So the questions I'm interested in as part of my project is looking at how is prioritization of uncertainties in the management currently addressed. This is really a gap at the moment. We don't really understand how this is happening, especially in this context. And then what can we actually do to improve this? I want to put in a little bit in terms of what are the techniques and methods we can actually use to handle uncertainty. So this is a framework that I developed quite a few years ago of simply thinking about what are the tasks involved in uncertainty analysis. We want to be able to identify the uncertainties, prioritize them, which is the focus of what I've just been talking about, reducing the uncertainties, as Chris had talked about as well, describing uncertainty and propagating it through an analysis, communicating it to decision makers, and having some steps in place to be able to manage the remaining uncertainty afterwards. Just to finish up, I want to focus on one particular type of technique, which is the idea of how we talk about our conclusions. It's not even a question of how we communicate the uncertainty that we've quantified, it's how do we talk about the conclusions. So here we have a case study. There was this quite influential paper in 1997 quantifying the global value of ecosystem services. And we can actually see that as part of their abstract, they've already had some hints at uncertainty within them. They've said that their estimate of the current economic value of 17 ecosystem services is based on published studies and a few original calculations. So they've tried to boost the acceptance of their result a little. So, no, this is based on published studies. It's got some weight behind it. This is part of the argument that's being supported. The value is just estimated. So if we talk about an estimate, it means it is possible to get a different estimate, right? It's not just the single right answer. It's possible there's some range, some differences in there. And they've then talked about the range, so they've actually performed some kind of quantification of uncertainty, coupled with an average. And then they, interestingly, then make an extra argument to say, well, even though they've made a range, this range is still only a minimum estimate. And this last statement about global gross national product, it doesn't look like it's handling uncertainty at the face of it, but what it's doing is appealing to a comparison. Say, well, how significant is this result? Well, all we need to do is to compare this number here to that number there. And so even if you don't trust this number there, it's still very important. And so this idea of being able to compare to something is a quite frequent way of dealing with uncertainty. So this paper was actually quite controversial, and there were quite a few criticisms published over time, to the extent that this is actually an interesting case where the authors then came back and decided they needed to publish an update and kind of a defense on reflecting quite a few years later on what the role of this paper was. And so here, their framing of uncertainty is interestingly completely different. The evaluation of ecosystem services can have many potential uses, and so they say this paper that we've just talked about was clearly an awareness-raising exercise, and it was very successful for its purpose. And then deeper in the paper, they talk about the fact that this estimate is only based on a simple benefit transfer method, and tried to downplay it a little. And they've added a whole new section on caveats and misconceptions, responding to a lot of the criticisms that were out there. So what I want to do here is then to think about, well, how could they have written the abstract differently to actually capture the way they thought about the uncertainty in 2014? If they were to go back and rewrite that original abstract, what would they put in it? So they talked about, we have estimated the current economic value. Well, they could have said, we provide a preliminary estimate of the current economic value using a simple benefit transfer method. And they would already put that sign in that, you know, we're not expecting everybody to agree with this result. This is just our first attempt, and that's good enough. Here, I would switch around, rather than talking about a range first and average, and it makes more sense to go into the uncertainty, but more importantly, to emphasize that our assumptions result in this value, right? They know that their method, they knew even at the start that their method had limitations. So we might as well make that explicit here too, as a defense of that argument. And so here, I've again inverted it to make this comparison to give it more emphasis, and to really finish with that strong message that because of the nature of the uncertainties, the true value may be even larger. So the final thought I want to leave you with is simply that a powerful way of tackling the topic of uncertainty is to think about, firstly, how are the pathways that we're following leading to different outcomes? And secondly, that the language we use has a lot of power in avoiding fully committing to a conclusion. Thank you.